In the previous video, we saw the types of AI that exist and how they are applied in facility management. Now, let's take a deeper look at where this intelligence resides and how it integrates with the systems we manage in our buildings. Today, smart sensors combine multiple measurements such as presence, temperature, CO2 levels, light intensity, sound, and vibrations into a single compact device. Thanks to technologies like Edge AI, they can analyze information in real time, acting locally to reduce data traffic to the cloud. This provides speed of response, security, and privacy, critical factors in buildings where every second counts and data confidentiality is essential. Furthermore, these sensors leverage advanced wireless networks such as LoRaWAN, 5G, and Bluetooth Low Energy, allowing them to be installed even in older buildings or in areas where cabling would be too costly or impractical. This improves flexibility, facilitates maintenance, and allows for more cost-effective expansion of monitoring areas. However, sensors alone do not provide all the necessary intelligence. It is crucial to have platforms that organize, analyze, and convert this data into decisions. This is where systems such as BMS/BAS, building management systems, come into play, with examples such as Siemens DeSigo or Honeywell Forge, which are responsible for managing HVAC, lighting, and security. On the other hand, IWMS CMMS, integrated workplace management systems, computerized maintenance management systems, such as IBM Tririga or Archibus, focus on managing spaces, assets, and maintenance tasks. These systems form the true digital brain that coordinates the overall functioning of buildings. By 2025, these platforms will go a step further, incorporating generative AI modules capable of recognizing complex patterns and autonomously suggesting optimization actions. This will allow failures to be anticipated before they occur, optimize energy resources, and improve occupant comfort, taking efficiency to the next level. The big technical question is where to process the data. Edge AI allows information to be processed directly in the building, minimizing latency and improving privacy, which is perfect for systems that require instant responses, such as HVAC, lighting, or access control. Cloud AI, on the other hand, offers deeper analysis, capable of working with large volumes of data, building predictive models, and finding patterns that would be impossible to detect locally. However, it depends on connectivity and can introduce some latency. Ideally, both approaches should be leveraged in a hybrid fashion. The slide clearly shows this. At the base, we have IoT sensors that capture data on HVAC, occupancy, lighting, air quality, and energy. Above, edge computing manages real-time data for immediate action. Further upstream, cloud platforms perform advanced analytics and generate predictive insights. All of this feeds into analytics, maintenance, occupant management, and control modules, helping to create more efficient, sustainable, and future-proof buildings. For engineers, this means greater agility in detecting and resolving issues, less manual work, and greater automation. For finance leaders, it means reducing operating costs, optimizing investments, and having accurate information to support strategic decisions. Understanding how this digital brain works opens the door to exploring how AI directly drives energy efficiency and sustainability in the buildings of tomorrow. We've seen how digital technology and artificial intelligence are transforming energy management, but the real value lies in the concrete savings and sustainable impact they generate. AI makes it possible to optimize energy consumption and tangibly improve sustainability in buildings. HVAC, which encompasses heating, ventilation, and air conditioning, is responsible for a large portion of energy consumption in hospitals, shopping centers, and offices. Using AI-based predictive models that analyze actual occupancy, weather forecasts, and variable rates, the system adjusts its operation to avoid inefficiencies and anticipate failures, reducing consumption and protecting investments by minimizing breakdowns. Smart lighting also provides significant savings. Adjusting light intensity based on natural light and detected presence, along with continuous learning of usage habits, can reduce consumption by up to 50%, while simultaneously improving visual comfort and the user experience. Advanced monitoring extends these benefits to less obvious but crucial aspects, such as controlling CO2 to ventilate only when necessary, detecting water leaks by analyzing anomalous patterns, and optimizing waste management to reduce operating costs. All of this creates healthier and more sustainable environments with lower costs. In an office building, these improvements are reflected in an average reduction of 24.5% in energy consumption, an annual savings of more than €32,000, and a reduction of more than 18 tons of CO2, figures that provide solid arguments to justify the investment to finance and sustainability departments. A practical case is a corporate campus in Madrid, where 5 buildings and more than 2,500 occupants have managed to reduce energy consumption by 28%, save €165,000 annually, and improve comfort, recovering the investment in just 14 months. This confirms that AI is cost-effective and improves environmental quality. The innovation of the digital energy. Twin creates a digital replica of the building that allows scenarios to be simulated and adjustments to be tested without physical intervention, facilitating data-driven decisions and preventing financial and technical risks. For engineers, these solutions mean greater control and fewer emergencies. For financiers, they provide clear data that allows for ROI calculations and confident planning. With this foundation, we move on to another key field, predictive maintenance and operational optimization, where AI continues to offer significant opportunities for savings and efficiency. Now let's focus on an area where AI is demonstrating a decisive impact: predictive maintenance and operations optimization in facility management. Traditionally, maintenance was performed either reactively, that is, fixing something only when something breaks, or preventively, with scheduled checks, even when the equipment is working properly. However, both approaches have limitations. Reactive maintenance generates high costs and downtime, while preventive maintenance can lead to unnecessary downtime. Artificial intelligence is taking us further toward predictive maintenance that anticipates failures before they occur, based on multi-sensor data analysis. Sensors that measure vibrations, temperature, acoustics, and power consumption tell us about the true health of equipment. Correctly interpreting these signals allows us to detect latent problems in critical systems and avoid unexpected downtimes that generate losses. Furthermore, this intelligence integrates with the management platforms you already use, such as CMMS or IWMS, automating the generation of work orders and prioritizing tasks based on their criticality and cost. This way, the technician doesn't have to search for problems. Instead, AI identifies faults and suggests the necessary actions, facilitating a faster and more efficient response. But AI doesn't just anticipate failures, it also improves operational organization. For example, it optimizes maintenance personnel routes to minimize travel and balance workloads, saving time and costs. It also predicts the demand for spare parts to avoid excess inventory or running out of key parts, and enables inspections with drones or robots in hard-to-reach areas, reducing risks and associated costs. If we compare traditional approaches with predictive approaches using AI, we see that reactive approaches accumulate high costs and cause up to 40% more downtime. Preventive approaches, while reducing these figures, still generate 15% of unnecessary downtime. In contrast, predictive approaches optimize costs and can reduce downtime by up to 85%, which is vital in environments such as hospitals or shopping malls, where every minute of downtime represents a financial cost and inconvenience for users. A real-life case that illustrates this is that of smart elevators, where acoustic and vibration sensors, combined with AI, reduced downtime by 72% and maintenance costs by 35%. This translates into significant savings and a much more reliable service. The typical workflow begins with data collection through sensors, which are analyzed by AI and machine learning systems to generate automatic commands in the CMMS, which are then executed by technicians. AI acts as a translator between complex data and the necessary actions, facilitating intelligent management. For engineers, this means intervening only when necessary, avoiding unexpected failures or unnecessary interventions. For finance professionals, it represents clear savings, less downtime, and a lower financial impact from breakdowns. In short, it means moving from a reactive model to an intelligent and proactive one. managed with data and anticipation. Now that we've seen how AI revolutionizes maintenance, in the next part, we'll explore how it also improves space management and the occupant experience. AI helps us avoid breakdowns and save energy, but it can also improve something fundamental: the efficient use of spaces and the experience of those who work or visit a building. Previously, many buildings were designed with a theoretical occupancy rate that rarely matched reality. In practice, some rooms are almost empty, resulting in unnecessary expenditure on air conditioning, cleaning, or maintenance, and other areas are always overcrowded, causing discomfort and loss of productivity. Now, thanks to advanced sensors and computer vision, AI can detect the occupancy of each space in real time, analyze usage patterns, and propose changes that allow for better redistribution of areas, achieving savings of between 15 and 25% in real estate and operating costs. The image shows how Room A is at 85% occupancy, while Room C is barely 15%. Given this situation, the AI suggests moving meetings from Room A to Room C to better distribute the use of spaces, avoiding overcrowding and improving circulation flow. Furthermore, the AI can automatically adjust temperature, light levels, and air quality according to the preferences of each person or group, something that not only increases comfort, but also raises occupant satisfaction by up to 22% and improves productivity by around 7%, critical factors in competitive work environments. The Comfort Management app, visible in the lower right corner of the image, allows each occupant to define their ideal conditions, such as keeping the temperature at 22 degrees or the lighting at 60%, and the AI takes care of maintaining those conditions automatically and efficiently. Thanks to these adjustments, a perfect balance between well-being and energy efficiency is achieved, even reducing consumption by 20% without sacrificing people's comfort. Furthermore, the AI facilitates space reservations through chatbots and virtual assistants that suggest the most suitable room based on historical usage, the number of attendees, or the specific needs of each meeting. It also guides people through the building, optimizing routes, avoiding traffic jams, and managing queues in common areas, something very useful in large facilities such as hospitals, corporate offices, or shopping centers. For engineers, all this means managing smart, dynamic buildings capable of adapting in real time to the changing needs of people and the operation of the building. For financiers, it means measurable savings, space cost efficiency, employee and customer satisfaction, and solid data that justify investments in technology and the continuous improvement of assets. Thus, AI not only takes care of machines or technical systems, but also ensures people's well-being, creating healthier, more efficient, and more pleasant environments. In the following video, we will see how this same intelligence can make a key contribution to safety and regulatory compliance within facilities, ensuring not only efficiency but also protection and peace of mind.